how do we actually create machine learning models, right? So ML model is composed out of a few different components. So first, you need to have a data set. So data, right? And machine learning models are really data hungry. You need to have a lot of data to be able to train them correctly. But that's not necessarily the case for every single model created out there. The most general classification models, which discern good from bad, are data hungry. They need billions and billions of samples. So Reversing Labs, throughout all of its existence, has thus far collected and classified over 10 billion files. So we already have a good starting point to create a model which discerns good from bad. But for us, we decided to create a model which ultimately benefits the human. So we said we want to create a model which not only classifies good and bad, we want to create a model which tells you, well, what type of bad something is. So let's say, Reversing Labs has decided to create a model to classify remote administration tools, right? And that's exactly what we did. So for us, then we started down selecting from this huge sample set and picking only the samples which are actually remote administration tools. So just rats. There's significantly less of them. And we're talking about a few 100,000 samples, right? Let's say it's 100,000 samples to start with. So how do you do that? So this is actually one of the biggest problems in data science. How do you down select and how do you properly label? Because how correctly you label something is how well the model will actually learn that something is a rat. So in this particular case, and quite a few others, the data labeling is something we did manually. So we have a quite dedicated team of reverse engineers and threat analysts, which went through our data set and collected all of the known open source and even closed source remote administration tools. So that's a pretty smaller data set than 100,000. Here we're talking about a few thousand. So let's say it's 1,000. So 1,000 different files, which represent about 1,000 different remote administration tools, right? They're unique families, all handpicked. So for each and every one of those, we know that we're dealing with a rat. So all of them are 100% correctly labeled because we manually verified. Okay, so that's great, right? We have our malware data set. So we have all the rats, they've been correctly labeled. What we don't have is something to compare this against, right? Well, aside from rats, you also need to teach the machine learning model what is not a rat. Not a rat. And there are a couple of different things which are not rats, right? Everything which is good, so goodware. So these are clean software components. They are all not rats. And other malware types as well. So let's say ransomware. And this might be counterintuitive. So why do you teach the machine learning model that something is goodware is obvious, right? You don't want to have false positive detections. But why would you teach it that something is not a ransomware as well? Because for us, when we have the machine learning model and want to do our classification, we want to make sure that the end result, when we say something is actually a rat, that we're as certain as possible that we're identifying only rats and not other threat types. So in terms of creating the model, all of these things are going to be concerned as false positives. So we want to eliminate those and focus only on the true positive detections, which are rats. And now, all of this is our data set, right? We have the data, it's properly labeled, what do we do next, right? Well, then we process the files and we create indicators. So this is also really, really labor intensive. To be able to correctly train the machine learning model to identify something as a rat, you need to properly describe it. We do these descriptions through indicators. And a lot of the times when we start training the models, we feel that the indicators are not defining rats or describing rats well enough. So we need to add as many as possible to define the behavior of a rat. And what do rats do, right? Well, they're network-based programs which allow somebody to execute remote commands. They take screenshots and do other things. So these descriptions is something we need to define through code. So our team of threat analysts and reverse engineers creates rules which map the metadata we collected to indicators which describe what rat is. So since these are human readable, they're really textual descriptions, they are perfect because they explain to a human what a rat is, but they also explain to the machine learning model what a rat is. So once we have the data set, once we have the indicators, or in machine learning terms, features, then we can train our model. And then by process of training the model, we have trained it to recognize rats only and to be able to describe what a rat is by using features which we call indicators. And that's the whole loop. That's how a machine learning model is created. And we create a machine learning model to identify rats. We create another one to detect ransomware, another one to detect keyloggers, and so on. There's about 24 different threat types. And all of them are ultimately going to be detected through machine learning models, which are highly specific and built in this particular way to identify only them and not other threat types. So when you get a detection, you can be sure that it's detecting exactly what we designed it to detect.